Hello, I'm Philip Marris. I'm the CEO of Marris Consulting. I've been implementing the theory of constraints, usually combined with Lean, for over 30 years, over 200 times throughout the world in all sorts of industries, designing and making cars, trains, aeroplanes, rockets, hamburgers, and many other things. The results obtained worldwide by people who manage projects are not good. You can take whatever reference you want. You've got here a study by the Project Management Institute, the PMI, of 2012, which shows what goes wrong in terms of meeting due dates and not spending too much money and all that. And well, I won't go into further detail about that. I think everybody realizes how poor the performance is when we do audits of certain companies developing new products. For instance, we regularly find that 0%, none of the projects are finished on time. And why is that? When these projects have been broken down into elementary tasks, right? You've got a work breakdown structure with 10 tasks for a simple project, 100 for a complex one, or 10,000 for a very complex one. And in each of these individual tasks, we've added some safety buffering time. So we have a sequence of tasks, each of which has some safety, and yet the project will finish late and go way over budget and all that. So let's try and understand why that happens. We've got all these tasks. In each of these tasks we've added some safety, a safety margin, and we've asked the people to commit to meeting those deadlines, and we've launched the project, and yet it will fail dismally. Why is that? Well, let's start by going back to basics. How does one estimate task durations? Let's use the most often taught formula, PERT, Program Evaluation and Review Technique, which you should learn by heart if you want to be certified by the PMI and so forth. And you'll learn in all universities talking about project management. So in this PERT technique, you're going to ask the people who know the subject well, the actors or somebody who knows the subject well, for three different durations: the optimistic duration, the pessimistic duration, and the most probable duration. Okay? And then you're going to use the PERT formula to determine the median duration. That's to say, the duration in which there is a 50% probability of doing it faster than that, and there is a 50% probability of doing it in more time than that. And that's the way one's meant to do it. Basically, nobody does it that way in the real world. It's very rare to find people using that. And why is that? It's not because the formula is wrong. If you had to do a task, you would get normally this sort of shape. I mean, it would make sense, doesn't it? Let's imagine that you're a mechanical engineer having to design a part for a new product. You might find when you start designing it that last month you did a part very similar, and you just had to bring out the design of the previous part, do a few little changes, adapt a few of the tolerances, and there it was done. It worked. Okay, so you worked within the optimistic time. Okay. But it might well be that this new part, although it looks like this other part, the specifications are a lot tighter in terms of strength, weight, or whatever, and it's a real headache to design that part. And you don't get it right first time, you don't get it right second time. It takes you 15 attempts before you get it right. Okay, so there is this curve. It makes sense. You know, a lot of the time it's normal. Some of the time you're really lucky, and some of the time it's a real headache. Okay, and that's life. That makes sense, and that's the formula people should be using. So what's going wrong? Why does that theory never occur in the real world? So why is there such a huge discrepancy between theory and practice? Well, Elio Goldratt, the founding father of the theory of constraints, wrote the book that launched the Critical Chain Project Management, the book called Critical Chain. And in it, among other things, he describes various syndromes, as he calls them, that explain the difference between the theory and the practice. The first one is the student syndrome. Okay, so let's imagine that you're a professor with a class of 20 students in front of you, and you're going to give them some homework. Okay, so you say, okay, please hand in your homework in 1 week's time. Okay. Oh, and they all go and arguing and saying that's not possible. We've got another big piece of homework to be done for this other professor just the day before, whatever. We can't do that. Anyway, because you're a nice guy, you give them 2 weeks to do the homework. Okay, and off we go. How many of those students are going to start that piece of homework that evening? That's what goes wrong. Although we have given more time than the time really required to do the homework, okay, since they're not going to start immediately, they're going to be wasting quite a lot of that extra safety margin that they've negotiated. Okay, and they might well end up starting, the night before. And it's when they open up the homework and they look at it that they realize that Murphy's has hit them, and they don't really understand at all what the question is, and they need help to to do their homework, and they end up either staying up all night, maybe getting it wrong, or not being able to hand it in, having to find some bad excuse about why they're late. Okay, so that's the student syndrome, and it's not specific to students. People in project management have that. I mean, you've got several things to do. One of them is late. This one's got some margin, so it'll sit there, and you'll be working on something else, and you'll always be wasting that kind of margin because of that, the student syndrome. The other one is described in various ways by various people, but let's all put it in a package around Parkinsons Law, right? The work will spread itself out to fill the time available. And this also hits project management. Imagine this time that you are a young, naive programmer in a company, and you'd been given the task of writing a piece of code for this new product. Okay, and it was estimated that it would take you 10 days. Off you go. And so you look at the work to be done. You say, hey, that looks a little like the thing we did last month, where we did something similar. So you get the copy of the code of this other project, you modify it just a little bit, you try it, you test it, and it works. It works first time, it's perfect. Okay, so let's say you finished it in 3 days. You really tested it, it's perfect. So instead of 10, you've done it in 3 days. So you go to your boss and say, hey boss, I finished. Wow, that's really good, in 3 days instead of 10. Yeah, that's really good. And so what happens? Well, the problem is, next time that they have to estimate the time for such a piece of work, they're not going to say 10 days anymore, are they? They're going to say, he did it in 3. So maybe we can just give him only 5 days, or if we're really vicious, we'll give him 3. Okay? So if you do start handing your work in early, people are going to start giving you less time to do your work. The task durations are often proportional to the seniority and the number of years you've had in that company. When you arrive, you might give some very ambitious times, but 10 years later, you're always putting a lot of margin in and using that margin. And that's not the only problem with this example. Imagine that you gave that thing after 3 days. The boss said, okay, let's forget about what's going to happen with them next time. And he said, okay, and they hand this piece of software to the next team that's going to do further work, right? The successor in the network. So this other resource receives a piece of work 7 days early, right? Wow, that's really good, well done. And does he start working on it? No. I mean, what's the rush? It's early. I mean, he's got so much stuff that's late. He's not going to start work on it at all. Okay. So the 7 days that we won will just evaporate and disappear. So that's how we have the strange situation in which we thought we had a number of tasks, each of them with a safety factor which would ensure that the project would finish on time. In fact, what's happening is that those safety factors that protect are all being wasted. Okay, so anytime anybody gets ahead, that advantage disappears. And it's only the problems, only the things that are overdue and late, that turn up and get passed on from one stage to the next. So you can never finish anything early in reality. It's only things that get late that will accumulate across the system. This phenomena is amplified by the integration point issue, well known to anybody who does any kind of Monte Carlo simulations. It's very simple. Imagine that you have 3 different tasks that all have to be completed before the following task can begin, right? It needs 3 different inputs. Let's assume that the first task finishes 3 days early, the second task finishes just on time, but the third task finishes 10 days late. Well, the next task can only begin after 10 days. It's also going to be 10 days late. Okay, so the integration point just amplifies the problem and ensures that when things get overdue somewhere, it's going to create a big mess. To give you another example, statistically speaking, if you have 5 different tasks, and if we imagine that each of these tasks has a 50% probability of finishing on time, you can calculate it for yourself. The probability that the next task, which needs to have the input from those 5 tasks, is finished on time is 3%. Now let's talk about multitasking. It is probably the main killer of performance in the world of projects. Okay. Let's imagine that somebody ends up with work planned on 2 different projects simultaneously. Okay, and that happens all the time. It might even be a lot more than 2 projects, in fact, because although software can level out the work and ensure that that doesn't happen in the planning, it's very, very rarely done that way, and we usually leave the problem to the people who will ensure the execution. So this person has these 2 tasks. Okay, he thinks, okay, that's fine, that's normal. I will do those, and I'll try and move along each of these tasks simultaneously. So let's say I plan to do one day on the task A, and the second day on task B, then back to task A, and so forth. I will switch back from one and to the other to keep them both moving. Okay, well, that sounds like a reasonable compromise, but what in fact happens is that their multitasking, their switching between tasks, is a lot more frequent than that. We do a lot of audits of this sort of situation, and quite regularly we find people who are multitasking to the point of switching 30, 40, 50, 60 times a day from between projects, right? So they're spending 5, 10, 15 minutes at a time on a given project before switching to something else, and that's a real killer. In the one-day training, of which this is a brief summary, we play a multitasking game. It's quite simple. We give all the participants 4 sheets of paper on which there are 4 tasks. The first is to write out the even numbers. The second is to write out the alphabet. The third is to write out odd numbers, and the final one is to write critical chain. We time them, right? First they do the first exercise, the even numbers, and the second, the third, the fourth, and we'd see how long it takes. Right, fine. And then we ask them to do it again in the multitasking mode. That's to say that they will first put the first of the even numbers, then the first letter of the alphabet, then the first of the odd numbers, then the first letter of critical chain, then back to the second even number, the second letter of the alphabet, and so forth. Okay, just as simple as that, with obviously something that everybody should be capable of doing, right? The result is, in that simple game, that people take 3 times longer than they did, right, with the same exercise. And more extraordinary, we find a lot of mistakes. People get it wrong. They get the letters of the alphabet mixed up. They can't remember the odds and the evens. Okay, so a lot of mistakes appear. And we play that game because it's just very, very representative, in fact, of the madness of day-to-day work in a project environment where there's strong multitasking, and that is the main killer of performance. We will see how critical chain doesn't get rid of that, but it limits it significantly. So we end up with this very corrosive environment where everything's late, there's a lot of panic, the priorities are not clear, the visibility is not clear, you don't know what you're going to be doing that day when you arrive in the morning, and it looks more like a madhouse. And you end up with an environment where a good project manager is somebody who manages to get his project done faster than the others, because he's just better at negotiating things, better in shouting about it, better about playing Machiavelli to ensure that his tasks get done faster than those of the other projects. Okay, and then you go down that road, and you end up by having most of the training of project managers to be all about how to present things, how to lead, and whatever. We've lost all the science and all the rigor and correct reasoning. The other victim is planning itself. That's to say, since we know that the plannings are not at all going to be executed as expected, that they're going to be dead even before the ink has dried, we don't spend time doing good plannings anymore, right? And the network of tasks, the work breakdown structures that we find are just very, very approximate and incomplete. We regularly audit these sorts of things, and we find there are 20% of tasks that either don't have a predecessor or don't have a successor, right? They're just sort of floating around somewhere there within MS Project. Doesn't mean anything. We find, of course, that more and more frequently people don't even bother to detail the resources that are going to be used in for the different tasks, and that people have given up trying to calculate what the workload is on that department or that person or whatever. And even worse than that, we end up by finding that the actual deliverables, what was meant to be done in the task, is not clear anymore. And it leads to all sorts of strange situations where somebody will say, well, what have you done? Why did you do this? That's not what I wanted. I needed this. Or even more absurd, somebody saying, why did you give me this? I never asked for that. I don't need that. So the plannings themselves, people don't waste time doing them anymore. So in this strange world of project management, where the sorts of behaviours of the winners is to make sure that they get hold of their resources before even they need them, because then they're sure that they've got them, and they keep claiming that they're using them when in fact they haven't been able to start on the project. All these sorts of things you see all the time. And others. I mean, we've got a beautiful collection now of what look like works of art, sort of Picasso sort of stuff, done with PowerPoint or with Excel. Very artistic, very interesting. And that's what they use to present to their top management, where their project is. It's just sort of clouds and arrows and that sort of thing. Because we've abandoned all rigor and all standardization of the way of presenting a project and saying, is it on track or is it late? And so you have these strange meetings where there's a strange looking PowerPoint with colors and arrows, and all sorts of silly decisions being taken when nobody really understands what's going on, and probably none of them in the room know exactly where the project's at anymore. In that kind of environment, everybody's managerial attention is focused on the projects that are down the line, near finish, at least halfway through or getting near to the finish. And nobody's looking at the new projects that are just starting anymore, okay? And so, they're just lighting the fires of the following year and letting, these huge problems appear in their back. They're not even looking. And so when, at last they finish the project they were looking at, they turn around and there's this monster. And that just seems to be the way of life. And there's absolutely no reason for it to be like that. I mean, as we will show, with Critical Chain, you can finish nearly all of your projects on time, or at least the reason that it will be late will be honourable, and not this managerial madness. Another characteristic of these chaotic environments is the extraordinary proportion of time spent by various people managing the projects, not doing them, managing or administrating or monitoring them. Okay, you'll have one person, sometimes teams of people on larger projects, whose only job is just trying to update the different project management sheets. Another person who plays around with the numbers and the timesheets. Yet another who does this kind of control and whatever. And then you have managements and managers and management teams and reporting meetings and stuff. And you'll end up with organizations where 10%, 20%, 30% of their time is spent not actually doing the project, but managing it. In fact, with zero value added, because as you can see, it would be better if they did nothing, wouldn't it? So before we go further into what is Critical Chain, I'd just like to make an important point. Everything that you will find in, for instance, the Project Management Institute PMBOK the body of knowledge of project management, or other sources that describe what is the rigorous professional way of managing a project. Critical chain is completely complementary to all that. Okay, indeed, we will show through the rest of the series that critical chain enables you at last to spend the time or to be in an environment which enables you to apply all those elements of the PMBOK, of risk management, of looking at task durations properly, structuring your work, breakdown structures, all the rest. Okay, so this isn't any kind of conflict. On the contrary, critical chain enables your organization to launch itself into many other subjects of improvement. So we'll see in the following videos, when we build up what critical chain is all about, how and why it's worth spending time getting some good schedules, some good project planning, because they're going to be robust, they're going to be properly performed, and that's going to give some significant performance. We will also see, by the way, and maybe now you can begin to understand how we're going to be able to reduce the durations of tasks, which will make projects go faster, and yet finish the projects on time. That's because we will ensure that all these safeties are not wasted as they are today. Okay, so that was a brief video about all the problems you will encounter managing projects in the traditional way. Please note that the underlying assumption that was there throughout, and that maybe you are using, is that to finish your projects on time, you must try and ensure that each of the tasks finishes on time. You're assuming that if the tasks finish on time, the project will finish on time. In the theory of constraints, there's a saying which says, beware, the sum of local optimums is not equal to the global optimum. And in fact, in project management, striving to meet the task durations of the individual tasks actually kills the project. Okay, so we will now be looking at how critical chain rethinks the planning and the execution of projects to increase performance and make it a lot healthier environment. Thank you.